Hello everyone, please subscribe to my channel, hit that plus button and share. In today's video we are going to accelerate faster than the rain. The goal of this project by Meanwhile in the Garage is to complete transformer high performance Yamaha YZF1000 R1. A motorcycle cockpit, particularly one designed to protect the rider from the rain, creates a new confined space around the rider. The rider head might hit the roof of our windshield, making the cockpit uncomfortable. Thus, the first tasks involve constructing a wireframe skeleton, which serves as the foundation for the entire cockpit structure. The skeleton is made from metal rods and chicken wire mesh. The rods are made and shaped to form the rough outline of the roof, providing the basic form and structure integrity. Once the wireframe is complete, the next step is to cover it with expanding foam. The foam is applied directly onto the chicken wire mesh using a spray applicator. As the foam expands, it falls away, valids within the wireframe, creating a solid mass that gives the structure additional strength. Once the foam curves, it can be cut, shaped, and stranded down to the desired smoothness. This where the rough, irregular surface created by the foam is transformed into a smooth, aerodynamic shape. By combining sanding blocks with the other power tools, the builder carefully shaves off the excess foam. As we see, he continuously checks the structure to make sure it adheres to the intended design. Moreover, the smooth surface achieved through the application of the filter will be crucial when applying a protective coating. To this end, something very special must be created, a heating device designed to evenly distribute heat over the supply is made. Its frame is built using a square tabular shaped bars that are welded together to form a rectangular shape. The frame must be strong enough while allowing proper ventilation and safety for handling high temperatures. Once the frame is complete, the next step is to install heating panels. The heating panels are infrared heaters known as for their ability to produce already controlled heat. To optimize the heat distribution, the entire of the frame lined with reflective insulation made of human foil. Without this insulation, a significant amount of heat would escape, leading to uneven softening. This is how they make. In this sense, this reflective insulation maximizes the heat ventilation, which is crucial for the precision of the making of the motorcycle. The wiring is carefully organized to allow control over individual heating panels. The control panel allows the operator to precisely adjust the heat levels, ensuring that the polycarbonate will soften uniformly. All heating panels must work correctly and the temperature should remain consistent across the entire surface. Testing guarantees that the heating device performs as expected, so there are no electrical issues or uneven heat distribution. After that, a large polycarbonate sheet that will serve as the transparent roof is being prepared. The material will be an ideal choice because it is lightweight, impact resistant, and heat resistant. But before the heating process, the polycarbonate sheet is measured, cut, and skewered over the previously constructed platform. In order to prevent the heat from damaging the expansion foam, an anti-thermal cloth has been placed on the top of the mold. The heater are turned on and the chamber begins to warm the polycarbonate evenly. However, polycarbonate must be heated to a specific temperature, usually between 150 degrees and 160 degrees. This is when it becomes flexible enough to mold without breaking or losing its structural integrity. The softened polycarbonate is placed over the mold and a vacuum is applied to pull the material tightly over its surface. This is a fast and efficient method for producing complex three-dimensional shapes while maintaining strength and transparency. Excess material is removed and edges are sanded smooth to create a professional finish. Then the mold is divided to form the walls of the module. The process is repeated in order to maintain consistency and efficiency throughout the entire building process. The sheet is again transferred from the heater to the mold, but the transition must be quick to prevent premature cooling. During this stage, it is crucial to monitor the vacuum suction to ensure that it forms correctly along the edge cut. Finally, the cooling time may vary depending on the thickness of the polycarbonate and the ambient conditions. Patience is required, as removing the polycarbonate too early while it's still warm could cause it to introduce wearing. The canopy is then trimmed to remove excess materials such as they did with the upper part of the module. Aligning the polycarbonate with the frames involves carefully positioning the canopy over the cockpit's metal structure. The use of alignment tools such as clamps and temporary braces helps the polycarbonate in place during this phase. Clamps ensure that the canopy does not shift while it's being secured, while temporary bracelets allow the builder to test fit the canopy before finalizing its attachment. After the polycarbonate is correctly aligned with the metal frame, the next step is to secure the canopy permanently. To do this, holes are drilled through the polycarbonate, the metal frame with precision. In this case, rivets are the preferred choice due to their durability and ability to distribute heat. As each rivet is installed, the canopy becomes more slightly secured to the frame, forming a solid connection. However, for areas where the additional flexibility is needed, such as around moving parts or hinges, bolts or screws with washers may be used to allow for slight movements without loosening the structure. Then, in addition to securing the polycarbonate canopy to the frame, additional metal support braces are added. As you see, these braces are custom fabricated to fit the unique contours of the canopy and the frame. Made from aluminum, these bracelets help distribute heat of the canopy across the entire frame. Once shaped, they are carefully positioned around the edges of the canopy and also attached using the screw and rivets. These reinforcements are essential for maintaining the structural integrity, especially during the adverse weather conditions. The polycarbonate must be able to withstand external pressures without deforming while maintaining a safe place for the rider. From this point, it is necessary to modify the motorcycle in order to install the cockpit safely. Since the cockpit is a substantial addition in the terms of weight, aerodynamics drag, the existing frame needs to be strengthened. The builder begins by welding additional support bars to the key areas of the motorbike's chassis. These support bars are made from lightweight yet strong materials like high-grade steel to avoid unnecessary weight. Custom brackets and mounting points are also fabricated to ensure the cockpit can be securely attached to this frame. The reinforcement provides the structural integrity needed to support the canopy, while keeps the bike overall handling. But as we said, the cockpit itself must be aerodynamically efficient. It introduces a new surface area that will affect how the bike moves through the air at high speeds. The seating position also has to be adjusted to ensure that the rider has enough space within the cockpit. This also includes adjusting the handlebar height and angle, repositioning foot pegs. To compensate for this, adjustments are made to the suspension system. To compensate for this here, if the front end becomes too heavy, it can negatively impact the steering. Heavier duty springs and shock absorbers may be installed to handle the increased weight, especially at the front end. It might be the installation of the cockpit also required electrical modification to ensure that all systems work seamlessly. This includes wiring for additional lights inside the cockpit as well as external lights. The polycarbonate cockpit is finally aligned over the bike. The builder ensures that the cockpit follows its natural lines, blending in with the bodywork to maintain an aerodynamic shape. At this stage, precise measurements are taken to ensure the cockpit is center and does not interfere with the rider's place. On this other hand, the shape of the cockpit affects some of the most important visibility points. As you can see, the original rearview mirrors extend outwards and their typical placement will be inside the cockpit bones. Once the new positions are identified, the mirror stems are either shortened or given a new mounting point. The stems are pressed with the shorter ones to fit enoughly out of the cockpit profile. In the meantime, other safety modifications are made, such as ensuring the cockpit is securely fastened with drive. The fact is that the motorcycles are often at the mercy of the elements, especially during rainfalls. Riders face decreased visibility, discomfort, and increased risks. It is so that its modification effectively turns the motorcycle into an all-weather vehicle. The cockpit's smooth curve shape reduces the air resistance, ensuring the bike remains streamlined. The vision is carefully putted so that as he drives, he can see well on the road. So this enhances visibility since the wind shape is is clearly curved and he can see clearly through as he drives, providing comfortability and visibility. The project stands as prime example of how smart design can transform a motorcycle into a more vehicle through the use of advanced material like polycarbonate and innovating modification both the structure and the aerodynamics. In this Yamaha, it has been successfully equipped and now one can see through and it's very fast. Also, it is simple to make it. The creator now enjoys, for he cannot be arranged and is very comfortable. His experience in mechanical engineering and dedication to pushing the boundaries of the vehicle design are more than ever. Indeed, this motorcycle prototype represents a step forward for the safety of the motorcycle.